Alright, this should be streaming. And yeah, let's get started. Alright. By the way, the music is from one of my favorite bands, one of the ones I really like, Rival Consoles, Persona, is the album name. Alright, and let's see what we have here. So, box64. Box64 is a Linux user mode emulator. Let's actually see what the site has to say. Right, box64 lets you run x86-64 Linux programs such as games on non-x86-64 Linux systems like ARM. Host systems needs to be 64-bit little endian. So, starting from that, it's obvious that it's a multi-platform emulator, not only ARM. Right. Yeah, there are several channels that have covered it. Let's open some of these, like reject. Why do you even have to ask me? Can't see like here. Right, so you can see here.
Public και Media Markt μαζί για ένα σπίτι όπως το έχεις φανταστεί. Ενώνουμε τις δυνάμεις μας για να...
So you can see it here like in action.
ARM processor. To be able to... It's very playable, but the resolution is set to 800p, and it has the same issue 88S product that I own, issues or audio issues. Run DirectX on OpenGL. This game has high input lag, but it is playable. Borderlands.
Okay, that's cool. Let's see more on projects. So it comes with a dynamic recompiler for the ARM64 platform, and it provides speed between 5 to 10 times than using only the interpreter. It has some high-level documentation here. Ooh, that's fancy. Yeah, maybe that's something to take a look for a later time. It's kind of high-level introduction. Yeah, blah 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 blah. Yes, yes, okay, let's see, compiling, yes. So you can actually get a pre-compiled version of it, but I already installed this in this machine and I know it works. But I'm actually interested. I'm actually interested in taking a look at the source code. So let's go ahead and. Okay. Let's see. Alright. Let's open it in Visual Studio Code. Yes, I trust PtitSeb. Actually, yeah, PtitSeb actually maintained the port of Raycast for Open Pandora, like a long time ago for the Open Pandora stuff. Actually, let's not use. Okay, so let's see. Typical build. We don't really have this chipset though. Like I'm running on the NVIDIA Orange, so this will be more compatible to this one. So let's try this. Okay. I have 12 CPU cores. this take a moment. This is a pretty powerful machine, by the way. It's NVIDIA Orin. It's 30 gigabytes memory. Cortex A78. I got it. It was sponsored hardware while I was working on Fex. Okay, so we can already take a look on the structure. Right, it seems to be splitting the Dynarec at least based on the opcode prefixes or opcode numbers at least. So each of them is a single instruction or something similar to that. No. It splits into a library. Okay. That's surprisingly few warnings for emulator projects. Okay, libtools. Okay, callbacks, wrapped. Ooh. I guess these are wrappers for the native libraries, right? So, if I remember correctly, box64 uses like its own loader, and then it kind of automatically wraps the host libraries. In hex and fex, I mean hex is a derivative, so anything I say about hex kind of maps to fex at this point. It's been a few months only of working. There are special libraries that are shipped, so these wrappers don't get generated on the fly. They are like pre-built as part of the building. Yeah, okay. It's gonna be interesting to see how this works. A lot of work has been put into this, as one can see. Okay, and it's built. And this works. That's a nice feature. Okay, and just to see what it actually does something. Let's see. So you actually, if you run something like that, if you run something like that, still fake. If you run something like that, it will actually launch. This is a little bit misleading. It actually doesn't tell me to try. It actually does try. So this is a native shell, right? But it was launched within the box64. So this way you can use any program, right, that is running natively, like Python, Bash, right? With the only choice, the only problem that you will not be able to tell the architecture correctly, right? So here I can try have a rootfs installed. So I can try to run an actual bus that is x86. Oh, this still reports this architecture. That's interesting. I wonder what's that about. Is it relaunching itself? Yeah, but here you can see it running native ls. And you can also see the performance. Right? It takes around 30 milliseconds to run emulative ls, and takes like 4 milliseconds to run the native ones. Okay, but that's not much fun, so let's see if there's something I can run that's interesting. Let's try GPU test. What happens if I try to do this? You can see I'm extremely unprepared for this. Oh, it needs libgcc, and that's not available. Okay. Let's try ini. engine heaven. Let's see, it has a start. Thing is, since it's not integrated and it doesn't run an emulated bus, you kind of have to fiddle with the scripts or set up what's called bin FMT integration. Okay, let's go here, yes, and then That's interesting. Okay, because that one has worked before. It's libcc again. Okay, let's see. Okay, it probably needs to be installed to work. Bin FMT. Bin FMT. Okay, maybe I can avoid. Okay, let's try reconfiguring it. Yeah, no conf install. I don't think it needs to rebuild anything, yes. Let's see. Yes, so now it installed those libraries that apparently it needs. Let me try to remove this one and see if I can still use the... it works. So it doesn't have to use the latest build, but it needs to find at least one version of the libraries. Huh? That's good to know. So that's working. It's actually running very decently. Consider that I'm also remoting to this machine. Right now I have it's connected, and you can see like this really jumps. Quite impressive. Okay. Let's connect. So, magic, right? How does this work? So you can see here some of the logs. I don't know how you get more complicated things running. Quite obviously, it manages to wrap OpenGL directly to the native libraries. Right, there's a lot of challenges doing the stuff. So before we dive more into architecture, let's take a look at the source code. Like file structure, right? Ooh, LLVM private generator. That looks fancy. I wonder what that does. I really like it when projects have like a short introduction here, what this code is supposed to do, or maybe like a readme or something. I should do this in hex-emu, because like if you know the project, this is kind of very easy to figure out what it's doing, but if you don't, this is kind of what is this kind of moment. Okay, I think this is fetching some struct information using LLVM. Why would it use LLVM? Let's use clang. Let's use clang. Yes, it uses both LLVM and Clang. Okay. So the name is kind of misleading. Packaging, okay, let's see, docs. Maybe I should have tried here to read the docs first. This is a changelog, okay, compile, usage, wine, okay. Some nice images, really nice logo by the way. Okay, source will look later. Systems, these are configuration for different tools. Okay. Oh, it has some call rate optimization apparently, and some flags, and malloc hack. Okay. Okay. This is the bin FMT stuff. Okay. Tests. Okay, let's see. Okay, whatever. I have no idea what this is. Must be some binary or like the right files. This is seems to be the output of a test run. Okay, and these are some XMM tests. These are interesting. They are from box86. Okay, I should try to run these actually. Let's try to run this. You can see I'm all over the place. I'm always so chaotic when exploring projects. Where is it? What is it? Whoa, it's conveniently built. Build slash bin slash box64, yes. I need to set up my environments in a better way. Bin, fex loader, yes. Fix passes then. Good to know. Good to know. Okay, let's see, boss. Bench float. Linpack benchmark. Okay, this also has these are the reference outputs, must be, yes. Okay, and it has some binaries to get things rolling, I guess. It's interesting. Let's see. And there we have the wrapper helper, which I guess is some automation to ZIP. Interesting people, I don't really know. Radzakin, okay. And ZIP, okay. I don't know if this is actually used. Okay. Okay, that's interesting. In fex, Clang is also used for similar purposes, not exactly this way, but in a similar way. But I've actually ended up using the Python, like libclang in X, which was kind of depressing because libclang doesn't expose stuff. Most of the stuff that Clang does, like the API returns unknown or internal error, or like the API is fixed for libclang, but it hasn't been following the Clang update, so it's kind of a useless library if you want to parse at this point. I mean, it will get you the basics, just not everything. But it's much simpler to drive it through Python, and it's much easier to install actually, because I had some problems with Clang. Did this build on my machine? Ah, let's see. What are the targets? I don't know how to list targets. I'm so stupid. Yes, just give me. No, I don't want any cookies. Of course, it's not simple. Okay, I give up. Rubber helper. Anyway, these libraries, I guess they're just pre-built binaries. This cannot be wrapped. Okay, kind of interesting how libc is not here. Is libc wrapped? How does that work? Okay. We'll take a look at this. Dwarf. Dwarf is the debugging information, as far as I recall. Let's start a nodes file. Save it. Okay. Let's see. Let's actually keep it on the side. I cannot hear it uses. Ships with, yes, these are like C++, libs, yes, okay. No, can I just pin this somehow? In. Okay, it does. Then if I open something else, so useless. Okay. Can I? Pinning means not being able to close it. Okay, let's just close this one. Okay. Yes. So there is the elf loader. Actually, the dumper of the elf loader. Private information about the elf. Ooh, relocations, TLS. That's nice stuff. Yes, all of the relocation stuff. Yeah, this is GPL code, so it's kind of cannot be used directly in other non-GPL projects. But this is good stuff. So yeah, the code looks simple and clean. Not sure if this would be like static or whatever, but plain C code, easy. No classes. Man, the C++ clusterfuck in fex is C++ clusterfuck, and honestly, I don't really see how it provides much of a benefit, if anything. Okay. Name section, the typical stuff you expect to find. Ah, it uses file for reading. That's fun. I just meme up the thing in AX. I actually wrote that loader for fex as well. It was back before drama happened. Spicy emu drama. Back before the fork. Okay, well, I guess what you would expect. It's kind of big. Okay. Yes, then emu. So I guess that's different than the Dynarec. Are these the interpreter ones? Let's grab this. Opcode, next up. Is this decoding and get segment opcode fate? Okay, that's like a big. Ooh, it's decoding. It's decoding and also dispatching, but not actually emulating. Like where does this add come from? Let's see, this go. This is very similar to the ARM core I used for like VBA ARM. It's very similar structure. It has B and NOP, and the NOP has. Okay, so this macro kind of expands, and this is like the core operations, right? And these are the writes. How are flags handled in this case? Like, I guess flags are an implicit argument. Yeah, they are. You always get the read and write them, so you don't need. Okay, so you have like these common handlers for various variations, right? And then you have this kind of decoder dispatcher loop, which instead of getting generated from a list, like IX has a list, this just hard codes the decoder. This is bound to be much faster, honestly. It's kind of not as pretty, but much faster. I guess kind of this is also what I want to use for hex-emu. Just want this to be more or less generated. Okay, and then yeah. This, what is this? Word 0. I have no idea what these are. Ah, just a pointer actually. It should be a pointer. Ah, this could be a register or a memory reference. Smart. That's good. I like it. Kind of reminds me of the gadget approach in Raycast. Ah. Okay. No idea what this is. TV. Okay, whatever internals. Okay, writes, reads, yes. These are just used for memory dereferencing. Like, took me a moment to realize that, but these are just pointers, right? Or are they? What are these? Ah, no, they're not actually pointers. Ah, they're registers. Let's go down the rabbit hole. That is open. Yeah. Okay. So these are the parameters. Where are they set? It's not set anywhere, huh? And these, each of them has its oped, but where is oped set? It's not set like that. but it's set like that. Let's take a look. Magic. Getting lost in the magic. Okay, I'll be right back. And I grabbed an apple. Okay, let's see. I like how these are named runs. Like you're just running this whole prefix. I guess this kind of finish is also required in interpreter. You don't want to be slower than this. Okay, F8. I guess this is where op X. Yeah, a little bit of documentations would have helped just to get the names right, actually. Okay. So here you have oped equals something. I guess those are the common encodings. And I guess this. The rex, it's passed. Some value byte. What is delta? What is offset? No one knows. Okay, you have the emu instance, and this returns a pointer to the registers in this case. This could be vex or something. I have no idea. I guess this can also return, like, yes, directly a memory pointer. But that's really smart thinking there. Kudos. You don't share so much unified decoding. But it's kind of trickier to understand the whole system or be able to do meta-analysis. I don't know about the whole system, it's harder to do meta-analysis, right? But you just can click through your way and figure out how everything works. There's no magic involved. That's kind of nice. Also, everything is in a single pass, less magic involved. That's also kind of nice. Okay. So I guess these are all the random solved decoders. And, must have been tough to write all that stuff. Let's look at this later. Test. And I guess that's similar. I guess x87. Yeah. Oh, some codes are written directly here. That's good, so that's not only the coding. Yeah. Now this is totally like the VBA ARM core. VBA ARM. Yes. See, this kind of doesn't have functions, it uses defines just to merge everything together, right? And then it builds bigger helpers out of these defines, and then specific opcodes. I think these are also cases. The end. No, this is just op end. Yeah, I don't know why this. I guess these need temporaries. Anyway, so some of the code is kind of like that. And then it has like this kind of multipliers for the coders, and then it starts, and this is for 256, then it starts building like higher and higher level blocks, like say, including decoding, like cases directly, and all of the common code, and here you have the opcode, opcode 2 and base. Base is for the offset, opcode and opcode 2 is without and with flags, right? And you have along while this kind of only decoding. The other one was mostly the opcodes. This is mostly decoding, right? And after that, it has a big switch table. Some opcodes are here directly. Other opcodes are pre-decoded. It's a big source file. Yeah, see here, this handles several cases with a base offset. Kind of similar idea with this run system. I guess I think these are the extra operations here. Yeah, see? And then it has this I lost it. I saw it and I lost it. These macros that generate like for a big range, SB, SBSE, and it also has like common decoding, and it's kind of the defines kind of split all together, I guess, in some ways. And these are like kind of quote unquote one-off opcodes that are manually decoded. They are disabled for now. Yeah, and it makes an opcode hash, and then it has here. It's kind of similar idea, like similar use of defines. A little bit cleaner, I would say, box86. But then the other one is ARM, so you have to you have the option of decoding the whole table in one switch case. Like this was 12 bits, so it kind of ends up being uglier. Like x86 is complicated, but is because it has grown up in ages, it's somewhat more modular, if I can say so. Like the coding simple instructions is simple, and complex instructions are complex, I guess. That's a vibe. Okay, that's a lot of manual labor. TLS, pthread. Okay. I guess in the there is no private. Where are the others? Like, let's go here. Yeah, this. Where is this handled? Ah, primary operations. Okay. guess these are all of the operations that it can do. Yeah. And the third flag, okay. Yeah, maybe it's similar to bots. I haven't used bots, but I know that I think bots, B-O-C-H-S, like they kind of were the first people to use this, the third flag approach. Which makes sense in an interpreter. Okay, so there are the coders, interpreters, and the primary opcodes are here. Somewhere there must be the SSE opcodes. Or are they just... they're just done here. Okay, I guess that's an option. These seem less modular though. 2 years ago, 20 months, no, it's the same age. I don't know. It's not perfect. A lot of line noise, but it's, I mean, nothing is perfect. I would generate more of this instead of writing it by hand. This seems to be done by hand, but then you do have to write the generator. Different problems. Mux values. Structs are used. Okay, so but it doesn't use globals. Like it takes this emu reference everywhere. It doesn't use an implicit global. I can't say if that's a good or a bad thing, honestly. It is a thing, I guess. Okay, let's see. Librarian. Dictionary, global symbols. I guess it's the part of the library ranking. Yes. No? Roughly? Okay, libtools. SDL, what? It's kind of an interesting approach though, like you have all of the stuff preloaded in the memory, then you don't need to link. Like the libraries are built into the emulator, I guess less moving parts this way. Less files to wrangle around. Can't see the allure. I guess this run function can be used to run context and arguments. This must be doing somewhere full ABI handling as well. Yes, box. That's kind of odd. These helpers are in an odd this is a okay. Dynarec. Have so far avoided looking about folder, looking at the boring stuff first. Okay, let's go to the nodes. Code function 3 kind of similar to EASARM. Sometimes okay. Format that can point the code that is run before. Okay. 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 What else is there? Let's see what's here. Yes, there is no real separation between. I'll write that down. Let's say strict. I see in the context. Okay. What else? Malloc hook. Ooh, typo. I like this, whoever wrote this, I love them. Titseb, I love you, I love these comments. They say so many things. Little philosophy nuggets. Embrace strategy, no, as soon as possible, load link to the native and the exterminator. Yes. I mean, one person needs to define, right? Fun times. I like the macro use, man. I missed macros. I miss abusing macros. I don't know. It's like PTSD, you know, you kind of end up loving it. This reminds me of Java. Mangling. PP, FP, LLP. It returns a pointer. Yes. And then it's function. Takes a pointer. Two longs. And another pointer. Okay. Okay, so this, I guess both strategies are implemented. Okay. Special sauce for pressure vessel. Okay, these are the tests, the wrapper helper, hex-emu lib. Okay, let's see some of the wrappers. Wrapped. Then it's open all. This is part of the loader, I guess. For the guest, okay. It's kind of interesting how instead of doing elves, it has full custom support for this. I mean, you don't need to load normal elves, right? So. Okay, what do we need? Guess it's somewhat faster. Ooh. Library. Okay, some common loader. This source code is. I love it. I love it. I see myself in these comments. Okay, these are the types, I guess, of the functions. Okay. Okay. Like more preprocessor magic. But there is nothing really interesting in here, right? It just directly maps the things. Let's see, 80K. Okay. I love this is the best way to return null pointer. Now this does have mostly for the callbacks. Okay, but not much. Let's see. There seems to be minimal wrapping. I guess it doesn't do any struct repacking. Now it has the same run function handler, and then it has an args and a vargs thing. Like just one. I wouldn't use variadics here because variadics are a pain, but I'm really curious to see how this works. It's interesting some levers can be done simply directly like that. key. Okay, these are the library symbols. Okay. Okay. Well, that's a lot, but it's mostly more of the same, I guess. It's kind of a simple enough way to thank things. The question is, how do these runners end up getting executed? Let's look at OpenGL. Ooh, aha, aha, aha. Okay. This is a lot of work. Find externalize prompt. I know, this is for the attributes. What is it? This is for the attributes one, isn't it? I remember this one. Create nested list. Yes, I see. This one I remember having to. Oh my god. So it's parses and handles again. What about the mutexes and those things? I don't think it cares. Right? I mean, these are internal and supposedly. I mean, if you thank everything, so why not? A lot of work has been put into the libraries, that much I can tell. Okay, let's take a look how these things are interlinked. Actually, let's go to the notes. Yes, I want to find them. Sorry, guys, my mind was lost. Yes, here. Yes. Yeah, I want to find where it is. Definition? No? That's cute. Ah, here it is. I guess this is export Dynarec. The export dynamic. Ah, okay, so it is global. Let's put it in the notes. Ooh, it uses p threads. That's slow, guys. Slow. Okay. It's kind of odd. Some assumes integer arguments, 64-bit integer arguments. Don't you need to support like floats? Anyway, let's try this. Let's dive into the meat. Okay. Ah, there is RX5 as well, huh? Interesting. Okay, let's see what's here. Okay. Okay. Like a linked list structure, singly linked list, I guess. Yes, address, size, there is a hash. There is a done and gone, always test. If it's dirty. Okay. X31. No history on this file. Oh, GitLab is broken. Fun, fun, fun. Okay. Okay. Invalid. Yeah, gone is staged. Okay. If need log, yes. Then remove the jump table. Default, none is one. Okay, and then it unlocks it. This should be atomic. It's not. I don't know if it matters. So, second thing we have is a set jump table. map. That's working. Some table. No, this can be multiple blocks. That's my. I don't know how does this work. Does it create a chain? No, but they can be linked in multiple ways. Okay, mark range, free range, la 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 la. Native print Dynarec. These are the escape functions. This reminds a little bit of, I don't know, maybe Raycast, but not really. First time I see Dynarec look like that in this. What is native pass? What does this even do? Good question. If you reset, neat. Stock. This has some FPU stuff as well. That's interesting. It seems to be not very well defined. Okay, this must be a little bit platform dependent, I guess. Okay, this could be some decoding, like the equivalent of the run. Yeah, it is. And then instead of the actual handlers, you have the emit handlers. And the helpers are there. Oh, this is a very direct splatter. does some kind of pre-decoding as well, though. It's not fully directly splatted. So it can't tell if it needs, for example, the carry flag. It's just kind of read the codes and then this is with a constant. Okay, let's go back to that. Okay, it's x1. This is always. So there is no register location. The fuck? I guess because it's 8-bit. Okay. Get EB. Either is where to put it. In this case is ED. Okay. I like the emitter though. It's like not using an off-the-shelf emitter, is it? Okay, so it's doing somewhat like not using function, but some kind of register. I guess this is also similar to reusing the interpreter to some extent. Like this looks very similar. I like how it has instruction name as well. Right, but then it also does some analysis as well. Just does only x86 analysis, and then in the handlers, right. Is this ARM64? Yes. Wow, this uses 100 nanometer. Wow. Kind of envious of this. I don't like Vixel so much. I mean, it's don't get me wrong, it's not bad. It's just too much C++, too many abstractions. This is simple. A lot of work to get it done, but simple. Let's look some SSE opcodes. Okay, so this is like temporal register location. We have kind of one-to-one mappings. So this is actually an emitter function. I like this. Okay, this is very complex to get right. I mean, it's kind of convenient if somebody else has written the code for you. It's kind of a pain if you have a bug because it needs to be probably replicated. But it's a very simple design, very similar to the interpreter. And I mean, considering how much of a pain in the ass fexes and hexes IRs are, this is surprisingly fast though. I mean, is this just a run length? Where is this defined? Now this is very similar to the temporal register allocation I did for an LDC. It was 2005. And I think it's also similar to PCSX2's register allocator, maybe also Dolphin's. I mean, how else would you do it, right? You just run and discover things. Okay, I guess the next thing is how things are linked together to have a basic understanding. Cartoon beforehand. Yeah, this I haven't found. Static register allocation for okay, and okay. Let's see. This is the meat. Where is the meat? Custom mem. I mean, it has to be there. Why is it turned off? Ah. I guess it's because I haven't configured the project. how to find block from native address. It starts from the beginning of the list. Null. Okay. That looks kind of slow. It's kind of linear search, but also chunks in 64 bits. Is there no cache ahead of this? I'm really amazed how well this performs. So it's something with the 464. Okay, so there is a jump table involved. Wow, 1, 2, 3, 4 levels of jump table. Wow. Wow, so it's 18 bits, 18 bits. That's a lot. How many bits is that? $64. That's too many, actually. Okay. 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 Yeah. Right. That's what I meant. Okay. So it's page. So it uses okay. One byte per page. This is a little bit wasteful but faster. Like in fex I use a tree, which can be slower. Okay. Okay. I guess it is for the caching, no? Protection, remove protection. Okay. Let's see. Let's go into JIT. And let's see how does it branch around, like if let's see, return. This is special instruction. Okay, what about C3? C3 is red. My bad. Red to epilogue. Red to epilogue. Let's see what this is. Oh my god. This is becoming complex. So it has a call return stack. So it loads CBZ add to the pop is the right address. If it's the right address, it jumps to jumps over. Oh, I like how it has no labels. Man, this really reminds me of the MIPS times. Lol. But it is extremely lightweight. I mean, you can't argue with that. You can't argue with that. Okay. Otherwise, just move the pointer and then just start extracting the bits. Why does it do BLR though? That's tricky. Okay, otherwise it doesn't. Okay, let's see about jump to next. Yes. Get some table address 64 IP. Okay, so it pegs directly to the pointer. What does this do? Nothing. What does this do? No. I like this pass thing. Okay, this is a very esoteric code base, but gets the pointer, the reference to the row, I have no idea what that is. Get the jump, it jumps there. So I guess it allocates pages and then that's it. Kind of knows that its backing table is for a very fixed destination. So in that case, this is more optimal than X, because we have to do the compare here. It also doesn't need to do any unlinking on any of that stuff. Okay. Well, I'm gonna take a break. I have first impressions. Yes. Okay. Okay. That's also a lot of work, all of this. I don't know what these pass zero things are. Ah, it does 4 passes, eh? Okay. Kind of similar to SHIL. So I can understand all of this. It's a nice design. A little bit too much manual labor for my taste, and I mean it's also esoteric, but what isn't esoteric at this level? No. Okay, so the whole logic is run 4 times. Okay. So there is some metaprogramming used to simplify this thing, right? That's how it does its multiple passes, just to generate it. Yeah, but the question is like, what do these things? I mean, do they run multiple times? Oh. Okay. I can relate to this. Yeah. Yeah, something like that. Something like that. Or maybe the functions have extra, right? So there is like that. Step name to I don't know. But they can all be overridden. Not exactly sure. Alright. Alright, let's take a look at the system calls actually before wrapping it up, and then this is a full exploration. Hex-64 syscall. Okay, these are some flags. So there is a wrapper, but I guess uses the native one. Yes, there is like a pass-through. Okay. Then they're handled manually. Where was it? Yes, here it was. Oh, it doesn't do massaging for 64. It's much easier, yes. That's a D-range, that's a few structure code, marshaled. I like this inline debug stuff. Oh my god. This code looks like it could be easily a pain in the ass to maintain. But then again, there's no way, it's impossibly hard to write an emulator that's actually pretty to the eye. Like all emulators, they are a pain. And that's a statement. It is incredibly compact, I have to give it that, right? It's incredibly compact. Like there is duplication at times, but overall the code is incredibly compact. It has far less ceremony. Okay, I think we need. I need to make a verdict. Let's say here. Okay. Libraries, syscalls, okay. source, okay. Ooh. Concise, yes. Modularity is low, and there is limited separation of concerns. Yes, there is limited separation of concerns and a lot of I'm being a little bit harsh there, but hey, it's true. What can I say? But it's concise. Yeah, it has. Okay, let's give a review. Just to wrap this up, I guess. Let's give an overall review. It's kind of a simple code base. Like I don't know how long this has been, maybe an hour, and I have most of it under my belt. Naming isn't bad. Naming is quite good. Yeah, naming is quite okay. Like folder structure is fine. Like we were able to just navigate the project, no problems. Files do contain what you expect them to contain. Yeah. There is no C++ involved, which makes it kind of simple. You just have to think about structures and functions, and I mean, you kind of think C++ as a positive, but coming from fex and hex, it's kind of a negative in some ways. Like, because it promises you can do some things, but then you actually can't. I'm not quite sure what to make of this. I'm not quite sure. Let's see if I can add here. If I can add here me. I mean, this is not my most unprepared live stream, but all of my live streams are unprepared. I'm not so great at being prepared. Oh my god, lighting is horrible. It's okay, I don't care. You have to suffer this. Yeah, at least I'll be looking the right way. Okay, yeah. So yeah, I do like kind of the naming of things. The file structure is quite simple. I was saying C++. Yeah, C++ overcomplicates some things. There is quite a lot of files, but they are okay cut. There's some repetitions like that stuff here, and then it's kind of not clear, like this opcode is here, but then this is mixed up with encoding. I guess for some opcodes that are unique it doesn't matter, but kind of makes visually separating things harder. But that's just a nitpick, right? It's okay, you can just imagine this is a function. And like there are these comments where you can find what you want, so it's I don't know. It's not bad. It just upsets me, this kind of coding sometimes in interpreters. But it's not bad. I mean, it's certainly easier to follow along than the VBA stuff. At least it's not all through several layers of defines. So you can actually just set breakpoints here, and it should work. Yeah, it would work. Yeah, let's make a note that uses a custom emitter, eh? Super lightweight, macro emitting, no labels even. So this code base kind of goes away with all of the complexities of modern life and modern programming and all of the overhead, and it just kind of goes for it, which I kind of advocate for actually. It's straightforward. You can understand what's happening. There is a lot of macro magic and like meta programming through defines, like these multiple pass things or all of these things that mean multiple things, and you have to dig through them. But I mean, I've written huge amounts of template-based meta programming, so I'm fairly comfortable with that kind of style. I mean, for me, this looks easy to read. It has its intricacies, it has its magic, but you know, it's not crazy. Yeah, the structure is kind of okay. The code size is moderate. Somehow, even though it's supposed to be like less advanced coding techniques, like no C++ on the plates, it feels more manageable than hex or fex, which I guess that's more of a comment on the failure of design in those projects. Yeah, it includes its own loader, like a lot of code, a lot of functions, but most files are not too big, around like the 1,000 lines mark, which is very sane if you ask me. Like 1,000, 2,000 lines of code is my limit for most things. Yeah, it's very decent. I kind of like this idea of embedding the wrappers inside the handler, right? And then I don't know exactly how the loader hooks them up, but that's kind of nice because then you don't need to locate all of these extra files and load in the guest. I guess in our case it wouldn't really work as well because we need to run the guest loader. So for hex this would be more troublesome. It does give it an advantage though in performance, like all of these not running the original code. Also a lot of thanking code is run. Yeah. Overall, this is kind of my notes, right? It's more of a basic design. I would categorize it like especially the kind of emission it does. It's very similar to me from the null-DC PSP and a little bit raycast. I guess it could be some way similar to Dolphin, though it doesn't use C++, so that's not happening, thankfully. Yeah, it's also a little bit similar to PCSX2, but this uses far more macro magic, and I think PCSX2 now uses more C++ and somewhat more abstraction. It reminds me like late stage non-IR designs in the decoding. Simple, it's lightweight. Yeah, I'm surprised by the performance that doesn't have register allocation, so this is performing too fast for what I see. But then again, this might just be a comment on how badly hex and x perform, right? You don't. Also, this avoids a lot of code being run. This runtime library I haven't found. Like, is there a libc in the wrappers? Where are the wrappers? Source. Ha! And that was good. 3 times in a row. Wrapped, generated. Yeah, that's the basic stuff. Not too much generated. This syntax looks also very similar to the initial libraries, like this kind of micro magic and all of that stuff. I'm comfortable around this source code, I would say. There doesn't seem to be some kind of plonk linking, but it just uses indirect pointers, which I don't know how expensive they are in ARM these days. It doesn't seem to do multi-block. It does seem to do some kind of at least flow analysis for deferred flags and that kind of stuff. Yeah, let's see. There is a wrapped libc. Yeah, there is. Oh my god, this is bound to be huge. Oh my god. I don't even want to imagine what has to go on in here. Yeah, also similar a little bit to qemu in style. I mean, not in the generator. Like I haven't looked at the qemu generator, but the syscall handling looks kind of similar. I think there it's also in a huge ass switch. Yeah. Interesting takeaways. Well, I like how lightweight it is. And considering how agile the performance is, it makes sense. I like how lightweight the emitter is. I kind of hate how heavyweight the emitters are. I like how it packs the wrappers internally, so it kind of fakes the libraries. That's kind of innovative. In a way, you don't need the rootfs thanks to that. It also makes more sense, right? You don't like to fully replace the libraries, and if you have your own loader, you don't really care. Yeah, it aims far less though for some other aspects, like if you try to open a library file, it will not be existing. It's all just imaginary. So it can support custom loaders. It can support a lot of that stuff. Alright, I hope this was interesting to the no persons that watch this. I mean, why would you watch me dissecting an emulator source code for like 2 hours? I don't know. If you did, find something better to do with your time. Seriously. But yeah, these are fun notes. Maybe I'll wrap them up into a nice post. That's all. Cheers.